Hi, I'm Mylan.
And I'm Mike.
We are freshmen at the Milwaukee School of Engineering, and we are creating a final project through the concepts that we learned in ME191 class.
Using MATLAB, a lab jack, and a digital breakout board to control two-stepper motors, we are essentially creating a sun tracking mount for a solar panel.
We are linearly calibrating 4 photoresistors in a blackout grid, and then we are using the E-analog in commands after shining a light source on these to determine the voltages on each photoresistor. We are then using 2 stepper motors to move the solar panel through E-digital out commands because the stepper motors are connected to the E-digital breakout board. And then after positioning the solar panel to receive the optimal amount of sunlight, we'll use the changing voltages received by the photoresistors to keep moving the solar cell to keep it in the optimal amount of sunlight. We will then end the program by pressing a switch, which will end the while loop and if loops that we are using to control the stepper motors and the E-analog in commands. First, we position the photocells in the maximum amount of sunlight, so all 4 are receiving approximately the same amount. This will calibrate the high end of the voltages. Ready? And then we will put them in complete darkness or just take away the light source, therefore calibrating the minimal amount of voltage that each photoresistor will receive. Alright, the light up. Alright, after positioning the light, we will run the program so that the mount will be moving. Right now it is using the analog in commands, and so each photoresistor has a different voltage that is inputting. After the top 2 photoresistors versus the bottom 2 photoresistors determine whether the mount will angle up or down, the side 2 versus the other side 2 will determine which way the photocell is rotating. We are using the analog in commands again for the photoresistors, and then also the E-digital out commands to control the stepper motors. Throughout this whole period, we are inputting the voltages received by the solar cell through E-analog in commands, and we will be graphing that. We will then end the loop using the switch and an E-digital in command to read the switch. And this is the graph that the program produced. After the initial adjustments, the upward trend is due to the solar panel moving towards the light, and slight downward trends are from Mike repositioning the light. Otherwise, you can see that the program was successful, and our final project achieved its objective.